Okay, guys, I want to help you out a little bit with this. Now, this is just kind of my generic drawing of how sea surface salinity varies with latitude. Always look at this axis. This axis is salinity. This axis says latitude. 0 latitude is the equator. Okay, 22 is the tropics. Okay, and 60 is about the latitude of what? Seattle. Okay. In the northern hemisphere. Remember, Seattle's not in the southern hemisphere. But these are also the areas where we get a lot of rainfall. So briefly explain what this graph shows. It does. It shows how sea surface salinity varies with latitude. Okay, let me actually draw in temperature. Now, you guys, you know that if, let's say, this winter has been a little too cold for you, where are you going to go? Are you going to head north or are you going to head south? Okay, you're going to head south, and where you're going to head is towards the tropics or the equator. Now, I love it when students say, I hate rain, I hate cold, I'm going to the equator. Well, it rains every day in the equator. It is warm, but it rains every day. So if you really don't want any rain, you got to go to the tropics. Go to Cabo San Lucas or something. It's very dry there. But what you know is the overall relationship is that, hey, it's a lot warmer when you go to the equator and the tropics. All right, and so if we put temperature here, this would be low temperature and high temperature. Okay, so if this is temperature. All right, so let's go ahead and briefly explain why sea surface salinity varies with latitude. Well, the other thing we have to add on here is, what's high salinity and low salinity? These peaks are high, so our scale is exactly the same, high and low. Okay, but it doesn't really have a whole lot to do with temperature. It does a little bit. What we do is we have areas of really high sea surface salinities, and those are because evaporation, okay, evaporation far exceeds rain or precipitation. Same here, evaporation exceeds greatly rainfall. Okay, and remember, this is about those horse latitudes where we talked about the poor horses that, they need to drink a lot of water. If the sailors got caught there, they probably ate their horses or threw them overboard. Now, notice this little dip here at the equator. That is because it does evaporate. There's sun, but every afternoon, so that means approximately equal, it rains. Okay, so evaporation is approximately equal to the amount of precipitation or rain that you get. So that's the dip. Now let's go up to Seattle or up to the higher 60-degree latitudes. What does it do every day? It rains. So rain or precipitation greatly exceeds evaporation. Let's pretend that there was actually a sunny day in Seattle. A sunny day in Seattle still is not at all equivalent to a sunny day in the tropics or equator. Remember that concentration of the sunlight is concentrated here. And so what sunlight you're getting, even in the middle of the summer on a sunny day in Seattle, is pretty weak sunlight. So, even if there is some evaporation, what does it do? It actually rains a lot. And so rainfall. And remember, what makes the amounts of salts in the water are constant, and that's happened over the many billions of years that we've actually had the ocean. But to make something more salty, you would remove water. So in evaporation, it removes water. Okay, and precipitation adds water molecules. And this is what makes the water more fresh or less salty. And this is, removing water molecules is what makes the water saltier here. So again, right here, rainfall greatly exceeds evaporation. And what's that mean? That means low salinities. Okay, this means high salinities in the tropics. If you ever go diving at like Cabo San Lucas, you jump in the water, and first of all, you taste like, wow, this is like yuck, and all seawater tastes kind of yucky. But if you get this stuff in your eyes, it even stings more than typical seawater because it is so salty. Because with all that evaporation, those salts are concentrated. And kind of interesting up here, you not only do you have a lot of rainfall, you have a lot of runoff. And I've actually been on a boat with an oceanographer off the Columbia River. And he actually took a glass full of water and drank it right out of the ocean. And it was because there's so much water coming out of the Columbia River. He timed it for low tide. And, the amount of fresh water going right along the surface was really, really great. And so the water was fresh. I wouldn't suggest doing that because of giardia, but this was like 20 years ago. All right, you guys. So it looks like we covered all of this, but this is really important, is to understand that salinities vary because of evaporation and precipitation.